Well, good day to you, ladies and gentlemen alike. Just thought I'd deal with something that seems to be a regularly occurring thing that pops up with people saying, how do I get this to work? Why doesn't it work from the track? It works all right from every... We'll just go and deal with some basics. Literally no need for fancy equipment or anything in the nature of test meters. Hence why you now join us from what may be the first, although quite probably the last production of the Scruffy Workbench Film Company. Initially, one of the ubiquitous 060 Triang chassis, one that's actually just arrived with me in a job lot of a somewhat uncertain past, although it doesn't look too bad on the outside. But once the top's off, here we go again, one of those things, put that on there, wonderful, put them down here, blatantly refusing to do much of anything, certainly nothing that would make it recognisable as a working loco. Now, there's a number of things you can do, but the best thing to do as a first start point is literally to just take things into various small parts. First and foremost, we know the motor works. So the best thing to do in that case, since we're going to have to clean out the gubbins anyway, is just to remove the small screw at the rear. If you can find it through the general mess and detritus the previous owner has now successfully placed inside the body. I always did wonder why there was never sort of some protective thing on these engines, but that's, I suppose, heat and other problems. Always put your screws somewhere safe. A piece of toilet paper right there, you see. Like when you jog the table, you can guarantee you could spend an interesting 10 minutes finding it on the floor. Only other connection between the two, the usual little spade, which will, of course, take no end of fiddling and faffing to remove from the motor. This is a very, very clever design. It's put together to try and infuriate you as much as possible. Now we know that's working. Okay, it may need a remag. Indeed, it may need some of the dust and what appears to be small particles of wire wool removing from it. I suspect somebody tried some strange effort to clean it up, or at least the wheels, and thought wire wool would be ample substance for doing the job. I'm sure those of you watching from Electrical World will probably be cringing now. So I'll put that to one side and we'll clean it up later. Now, one of the interesting points with this really is what you can do literally without any form of meter. Simplest form of detection is the test bulb. Next best one of these. Even two wires will do quite a similar job. All you need to do is have your transformer across it, make sure it's turned up, give any motor a good chance of moving, but also when you're doing any work like this, going back to see where and when you can actually get continuation through a circuit. Now, the Triang chassis, it's an advantage. Whether it be the wire pickup or the flat blade pickups, there is always a point that's accessible on the bottom of the insulating plate. In this case, rivets, because it's the proper bladed pickups. I can see from here, on there, and that's a damn good flash. No test meter involved, no $9.99 from Wilco or any regular small store. So you've now got continuity between this point here and here. Simple. Could then move to the blades themselves. We have continuity once again. Now, let's go and take a look at the wheels, because of course there should be insulation between one side and the other. Let's take a quick look at the side of here. You'll see that all these wheels, and it's always worth a good close look on your own locos, when you get one that you've acquired from unknown sources, each one of those has a solid connection to the axle, with, strange in this one, the exception of the centre one. This particular one is made with insulation on both sides of the centre axle, right the way through, from one side to the other. However, non-bladed side, solid connection straight through to the axle. On your reverse side, as you can see, large plastic insulator. That is your insulation point between the opposite side of the track and the chassis. The chassis carrying the whole circuit from those wheels straight away to the motor, bolted solidly to it. So in this case, we're now down to here. What sort of connection have we got there? Well, one of the best things to do is to slightly flick those and just scrape away, because many of these will have formed a layer, especially if they've been used for a long time, around the back of the wheel, all the way around here. Point of that being, of course, if there's nothing going from there to there, there's nothing going to the motor. So, of course, what we can now do, if we place that back down on the bench, is now simply take that, now scratch a little bit of it, and whoopee, we once again have a through connection. Now, one of the important things to remember is those insulators. So common when somebody has got something that hasn't worked properly in the past, and take these out and faff about and then put the wheels back in and then mess around trying to line up all the conrods and put it back together. Not perhaps so much with these chassis, but more particularly with some of the ones that you find in some of the diesels, and also some of the other steam locos of later manufacture, where the chassis actually drops off the bottom and the axles are held within the top half of the chassis. It's so simple to get those the wrong way around. This one, not so much, but just imagine those two there. You have those insulators on one side, you have these side connections on the other. Mix one up, you've just literally shorted everything between one rail and the other. So basically, dividing this in half between motor and chassis, you can isolate anything. Continuity is one of the most important things between track and motor. Vast majority of failed engines are nothing to do with the motor at all. The vast majority are misassembly, poor contact, dry joints. Those themselves are quite difficult to find, in as much that between, for example, here and here, it's quite possible over a period of time for oxides trapped in the solder when it's made at the factory to form up into an impenetrable barrier to electricity. Externally, it'll look fine. Unfortunately, internally, nothing goes through. So all you're doing basically is eliminating this from this and purely making sure that everything you've got that leads between here and here ends up continuous. So once again, look into that to the side, and there is your continuity. You're now proven. If anything else really involves cleaning, don't be tempted to pull everything apart. Light cleaning is perfectly satisfactory as long as you get a reasonable surface on the back of the wheels. Doesn't need to be sanded down or hit with a Dremel. Literally just light rubbing over some very fine wet and dry can clear much of the oxide off and leave you with a reasonable surface. The importance of these, obviously, in their springing, you do need to make sure that that has got adequate pressure on the back of the wheel. But other than that, once that's done, and you've proven yourself from here to here, you've eliminated everything else. Now, there could be a thing that doesn't run at all, in which case you've now sorted that your motor is the source of the problem. It could indeed be, with motors which have been left for a very long time, that they just need that extra thud from a very heavy supply of power to get through the oxides and gaps that will form between these brushes here and the just brightening area you can see on the commutator. Even the action simply of sweeping them round a few times with your fingers can clear enough mess out of the way, even with a mucky motor like this one. And let's face it, this, as many of you out there will vouch, is nowhere near as bad as some of them can get, because of course it doesn't look like it's been in the back of a pond for 2 years. I hope that's of help. Hopefully a few people now will be able to delve into things with a little more confidence. Just go and take a look, take a screwdriver. If you're not confident with it, just come back and look again. I'm sure there are others that are on the group who will be able to give you some suitable advice, but there's some basic steps that hopefully will give you some leads as to how best to at least start attacking one of these locos. They're robust, they always were from Triang. The chance of you breaking something and burning something out, as long as you're being sensible, just using a normal mains transformer turned up to about half power, you shouldn't be damaging anything. You should at least be able to find your way through some basic checks. I hope that helps.